In this video, we're going to talk about standard deviation. And standard deviation is just the measure of variation, so how data vary from each other, based on measuring how far, on average, each data value deviates or is different from the mean. So we're comparing here each data value to the mean or the average. And so there are a few important characteristics when we're talking about standard deviation. So it's always positive, or it could be zero. If it's zero, it just means the data values are all the exact same. So if you had a list of the same data values, so like 5, 5, 5, 5, and 5, the standard deviation would be zero because they don't deviate from the average, which is 5. And the more the data is spread out, the larger the standard deviation is going to be. And so if you had a list like this, the standard deviation would be 0. If I had a list like 5, 10, 100,000, the standard deviation would be much higher than 0 because those values are spread out. Standard deviation has the same units as the original data. So I didn't give you units in my example, but let's say, these numbers represented dollars. And so if a standard deviation was computed, it would be in dollars. And so standard deviation, like the mean, it can be highly influenced by outliers because we use all of the data in the set. So with range, range only uses 2 values from a data set. So the high, it uses the high and the low. We take high minus low. In contrast, the standard deviation uses every data value to determine how spread out it is. And informally, we can think of standard deviation as roughly meaning the average distance for each data value from the mean. So let's look at an example so we can start to make some sense of what standard deviation really means. So we have 2 of these data sets and they each have the same mean and range. So I'm just going to compute the mean real quick. So for A, I'm going to add up all of these values. So 1 plus 1 plus 1 plus 5 plus 9 plus 9 plus 9. And I'm going to average those all out by adding them together and dividing by the number of data values. So 5 plus 9 plus 9 plus 9, and I get a total of 35. And then I'm going to divide by the number of values, 1, 2, 3, 4, 5, 6, 7. So I divide by 7 and I get a mean of 5. And then I'm going to do the same thing for set B. If I add 1 plus 5 plus 5 plus 5 plus 5 plus 5 plus 9, let me double check here. 1, 2, 3, 4, 5, 6, 7. Okay, we've got 5, 10, 15, 20, 25, 26, and then we end up getting 35 if we add those up. If we divide by 7, we still get 5. So we get a mean of 5 for both of the sets. And then let's look at range. So with range, if we do high minus low, we get 9 minus 1, we get 8. And then same thing for B, we have 9 minus 1 because it has the same low and high values, so we get 8 for that one as well. And so this is a situation where, okay, the mean and the range don't tell us anything about these data sets if we want to compare them with each other. So we can see that they're different, but the mean and the range don't show that because their mean and range are the same. So, but we can, at a glance, which data set appears to have a greater spread from the mean. And so if we're looking at the data, which one seems to be more spread out from a mean of 5? And I would say data set A. A is farther away on average. So if we look at each data value and we think about the mean being 5 in the middle, 9 is 4 away from 5, 1 is 4 away from 5, whereas this data set, most of the data sets are exactly the mean, and there are only 2 that are far away from 5. And so A has more values that are farther away from average than set B. So what we're going to do now is we're going to compute the standard deviation for each data set, and that will give us some more information in terms of the spread, since the range is not helping us differentiate the spread at all. So to compute the standard deviation, it requires a lot of steps. I promise you each step individually is not too bad, but you just have to go slowly. And if you need to, make sure that you've got these either written down or printed off in your notes, and you just follow these steps each time. And so I'm going to go through these steps as I go through the example on the next page. And so for example 2 here, we're going to look at data set A, that's the set we were just looking at, that had a mean of 5 and a range of 8, same mean and range as data set B, only here we're going to find the standard deviation. So to find this standard deviation, the first thing that we're going to do is we're going to write down the mean. So we're going to find the mean. And we already did that before, so I'm just going to write down the mean is 5, and I'll do that for this example down here. The mean is 5. And in both of these, n stands for number of data values. So both of these lists have 1, 2, 3, 4, 5, 6, 7 data values. So I'm just going to put a 7 there. Okay, and so step 1 is to find the deviation of each data from the mean. In other words, subtract the mean from the data value. So this right here, this is our step 1. Really, our step 1 was finding the mean. So we have to find the mean first so that we can subtract these two. So once we find the mean, that step 1 says take the data value. So in this case, the data value is 1, and I'm going to just do 1 minus 5, and that gives me negative 4. And then I'm going to do the same thing. 1 minus 5. And then 5 minus 5, and 9 minus 5. And then this one's 4 also. And then the next step is to square each deviation. So you're going to square this step. Now it's really important if you're using your calculator to put parentheses around the number if it has a negative sign. This is why. If you put negative 4 squared, you're going to get a negative 16, which is incorrect. When you're squaring negative 4, really what we're wanting to do here is negative 4 times itself. A negative times a negative is a positive 16. So you either need to remember both, that these answers in this column should always be positive, because you're squaring. So in case you forget parentheses in your calculator, just remember that they should always be positive. Or just when you're squaring, don't even bother entering the negative sign into your calculator. Or you could even do it by hand. In this case, 0 squared is just 0. 4 squared, 4 times 4 is 16. 4 squared is 16, and then this is also 16. So we're taking the previous column and we're squaring it. And then the next step is we're going to add all of these. So we're going to add these together and we're going to get a sum. So I'm going to add 1, 2, 3, 4, 5, 6. There's 6 16. So I can add 16 up 6 times or just multiply by 6. Most of the time, a lot of the time when you're doing standard deviation, these numbers will be different. So you'll just have to add those up. But in this case, I was able to do a shortcut. So we get a sum of 96. And then the next step, step 4, is to divide by n, which is the number of data values, if the data represents the whole population. If not, if the data is from a sample, then you have to divide by n minus 1. So it tells us in the example, assume that the data is for the entire population, not a sample. So what that means is that we're going to have to divide by n. Okay, so our next step, and so I'm on step 4, is we're going to take our sum divided by n. So 96 divided by 7. So 96 divided by 7, and I end up getting 13.7 and a little bit extra. So I'm just going to write down that whole number. So 13.7142857.1, and that's what we consider the variation. So this is the variation. Okay, and then our last step is to compute the square root of the result. So we're going to take the square root of that number. So we take the square root of 13.7142857.1, and I'll show you a shortcut in the calculator. Almost all calculators, scientific, graphing, have this answer key down here, which allows us to take that answer and it plugs it in for us so we don't have to type it out. So I'm going to find the square root button, which is right here. and I'm going to press second and then the negative sign, which will plug in that previous answer and find the square root of it for me. And so I'm going to write down the standard deviation as approximately, let's say I'm going to round to 3 decimal places. So that would give me a standard deviation of approximately 3.703. Okay, so now we're going to do the exact same process, but do the standard deviation for the second data set. So the mean is 5, so I'm going to take the data value 1 and subtract 5. I get -4. 5 minus 5 is 0. And all of these, since these are all 5, these are all going to be 0. And then 9 minus 5 gives me 4. And then I'm going to take these answers and I'm going to square them. So -4 squared is 16. 0 squared is 0. 0 squared is 0. So these are all going to be 0. And then 4 squared is 16. Okay, and then my next step is to add up the square deviation. So this is step 3. So we've got step 1, and then what I just did was step 2, and step 3 is adding these all up. So I add up 16 and 16, I end up getting 32. And then my step 4 is to divide the sum by either n or n minus 1, depending on where the data comes from. So since it told us to assume the data is from an entire population, we're going to divide by n. So I'm just going to write because data is from a population. So I'm going to take 32 divided by 7. So 32 divided by 7. And I write this number down. So 4.571428571. And then the last step, so step 5, okay, is to take the square root of that. So take the square root of 4.571428571. So I'm going to do the square root sign and then second answer. And if you can't find the answer button on your calculator, or you don't have one, just plug that all in, just type it all in, and you get the same answer that I do. And so you get this answer right here, and we're going to round to 3 decimal places, so 2.138. Okay, so we've got 2 standard deviations, one of almost 4, like 3.7, and the other one a little bit over 2. And so I want you to look at, let me see if I can scroll up so I can see all the, we've got the data set. So we've got the data sets where we have 1115999 and then a bunch of 5s and then a 9 at the end. And remember in the last example, it asked which data set do we think is more spread out? And we said data set A because it looked like that we had more numbers that were farther away from 5. Well, you can see that in the standard deviation. This is a higher standard deviation compared to set B, and so it means it's more spread out compared to set B. So now I want to follow up this example with one last standard deviation example where we look at 2 different types of data sets. We're not going to actually calculate anything here, but and let's look at these and see if we can figure out which one would be more likely to have a higher standard deviation and why. So let's say we're looking at the number of hours per week spent on homework by a full-time graduate student in a particular program. Okay, versus hours per week spent on homework by a high school student. Now, it's hard sometimes to answer questions like this because we don't know the particular students. We don't know who they are. We don't know what programs they're in. You know, it's possible that, you know, the type of student is going to vary. But on average, if I were just to take a guess, what you want to ask yourself here is which one is going to vary more? That's going to have the higher standard deviation. So when you think of the hours per week spent on homework by a full-time graduate student, my guess is that they would be consistent and that it would probably be a lot. So they would probably be spending a lot of time on homework and consistently a lot of time on homework because that's usually what graduate studies involve. Versus with high school, I would say it's less consistent. There are times where there's a lot of homework and there's times where the homework gets a little bit lighter, and maybe it tends to go up or down and vary a little bit more. And again, these are generalizations. I'm guessing. I mean, obviously, if you take a student who maybe is in 12th grade and is in all AP classes, they might be similar to a student in a graduate program. But I would say, if I had to guess, I would say um, the the second option, so the high school student, hours spent by the high school student will vary more compared to the graduate student. So I would guess that the standard deviation for this data would be higher. Now, again, we don't know how much higher, and this is a generalization, but that would be my guess. So hopefully this gives you, a good start to understand how standard deviation can help us understand data, and especially complement other ways to describe data like range and mean and median, mode, and mid-range.